So the question is explain the core IoT functional stack, which is asked for 8 marks in January-February 2023, and the same question is asked in 2022, that is July-August 2022. Okay, so core IoT functional stack. Since this topic is very lengthy and we have to minimize it and cut short it to 8 marks, I have just made an overall picture of the contents of this topic, okay, so that it will be easy for you to remember for the exam. So first we are going to see the three layers of the core IoT functional stack. So the core IoT functional stack consists of three layers, that is layer 1, layer 2 and layer 3. So what is your layer 1? Layer 1 is nothing but your things, that is your sensors and actuator layer. Layer 2 will be your communication network layer, and the layer 3 is going to be your applications and analytics layer. So in the layer 1, that is your sensors and actuator layer, you are going to learn about 1, 2, 3, 4, 5 and 6 parameters. So what are the 6 parameters? Power, mobility, frequency, data, range and object density. So we can take it as P, M, F, D, R, D. Okay. So power, mobility, frequency, data, range and object density. It is easy for you to remember. So under the power, whether your devices are battery powered or power connected throughout. Mobility, whether it is mobile and static device. Frequency, reporting frequency, whether it is low frequency or high frequency reporting time. Then data, whether it is simple data or rich data. Under the range you have range report, actually it is so short range or medium or long range, and object density per cell, number of objects per cell. Okay, and in the layer 2 you will be having communication network layer. Under the communication network layer you have four different sub layers, that is your access network sub layer. Under the access network sublayer, you will be studying about mainly the access technologies and distances, that is ranges and topology. Second sublayer is called as your gateways and backhaul sublayer. The third sublayer is called as your network transport sublayer, and the fourth sublayer is called as your IoT network management sublayer. Okay. And your final layer, that is your applications and analytics layer. So applications and analytics. Under applications and analytics layer, you will be learning three subdivisions. So first you will be studying about the different types of applications. So what are the different types of applications? That is analytics application versus your control application. Then you will be studying about your type of analytics, that is data analytics versus network analytics. And the last one will be your data analytics versus your business benefits. So this is the overall picture of your core IoT functional stack. Now we will go in detail with respect to all the different layers, and if I consider the mark allotment, since your second layer is very lengthy and contents are more, you will be 4 marks will be allotted for your communication network sub layer, 2 marks for your first layer, and 2 marks for your again third layer. So 4 plus 2 plus 2, you can write it for 8 marks. Okay. So moving on to the first layer, that is your layer 1, things, sensors and actuator layer, that is nothing but your devices. Okay. So as we have seen in the first slide, so first one is power, then mobility, then frequency, data, range and density. Okay, so whether it is battery powered or power connected, so this classification is based whether the object carries its own energy supply or receives continuous power from an external power source. Second category is your mobile or static. So whether your device is mobile or static. This classification is based on whether the thing should move or always stay at the same location. A sensor may be mobile because it is moved from one object to another, or because it is attached to a moving object. So the third category is low or high reporting frequency. This classification is based on how often the object should report the monitored parameters. For example, a rust sensor may report values once in a month. A motion sensor may report acceleration several hundred times per second. The fourth classification is simple, based on the simple or rich data. This classification is based on the quantity of the data exchanged at each report cycle, whether simple or rich data. Say for example, the humidity sensor in a field may report a simple daily index value, while an engine sensor may report hundreds of parameters from temperature to pressure, gas velocity, compression speed, carbon index, etc. Richer data typically drives higher power consumption. And moving on to the fifth category, it is your report range. This classification is based on the distance at which the gateway is located. So the distance at which the gateway is located. For example, what is the distance between your device and gateway? For example, for your fitness band to communicate with your phone, it needs to be located a few meters away at most, right? Then the last category is your object density per cell. This classification is based on the number of smart objects over a given area connected to the same gateway. Okay. So these are some of the example of the sensor application based on mobility and throughput. So coming on to the first category, that is for high mobility and high throughput. Some of the examples are in vehicle communication and infotainment, connected personal smart devices and video surveillance. High mobility and low throughput, vehicle telematics, fleet management, battlefield communications are the example. Low mobility and high throughput, digital signage, telemedicine, traffic cameras, connected electronics are some of the example, whereas the last where you have both low, that is mobility as well as throughput is low, you will be having the examples are industrial applications, environmental applications, home applications and retail applications. Okay, so moving on to the next slide. So the next layer is your communication network sublayer. So under communication network sublayer, you have four sublayers. So first one is your access network sublayer, right? And second one is your gateways and backhaul sublayer. And your third one is your network transport sublayer, and the fourth one will be your network management, that is IoT network management sublayer. So now we are going off with the first sublayer, that is your access network sublayer. So it is easy to remember by means of this diagram. What are the different access network sublayers? So based on the distance, if you see this diagram, less than 10 centimeter, you have NFC and EMV. Some examples. So NFC, you know that it stands for Near Field Communication, and EMV, Europay, MasterCard and Visa. So whereas you have less than 5 kilometer, you have wireless personal area network, wireless home area network, wireless field area network and wireless local area network. Whereas in between 5 kilometer to less than 100 kilometer, you will be having wireless wide area network and low power wide area network. Okay, cellular both licensed and unlicensed. So these are some of the examples. Okay, so network access network sublayer. So as specified, so under the access network sublayer, based on the range, based on the diagram which we have seen, the range estimates are grouped by category names that illustrate the environment or the vertical where the data collection over that range is expected. Some common groups are, so what are the common ranges you have? One is your personal area network, second one is your home area network, third one is your neighborhood area network, fourth one is your field area network, and fifth one is your LAN, that is your local area network. So preferably the IoT devices are mainly concentrated on these type of networks. So for example, the personal area network, scale of few meters. This is a personal space around a person, uh, and a common wireless technology for this scale is the Bluetooth. Next one is your home area network, which is a scale of few tens of meters. At this scale, common wireless technologies for IoT include, what are the examples? Zigbee and Bluetooth low energy. Neighborhood area network, scale of few hundreds of meters. The term NAN is often referred to a group of house units from which the data is collected. Moving on to the next category, that is your field area network. So instead of house units, here it is several tens of meters to several hundreds of meters. And field area network refers to an outdoor area larger than a single group of house units. The fan is often seen in open space. Therefore, it is not secured and not controlled. And the last category is your local area network. So, most of the devices, say for example, Ethernet, IEEE, IEEE 802.11 protocols. So it scales up to 100 meter. This term is very common in networking, and it is therefore also commonly used in IoT space where when standard networking technologies are used, such as Ethernet or IEEE 802.11. So next we are going to study about the different types of topologies. So the categories are point-to-point topologies and point-to-multipoint topologies, and the different classification are: one is star topology, second one is clustered topology, and the third one is your mesh topology. So you can see what is meant by a star topology. You will be having a full function device. To the full function device, you have a lot of other nodes, that is called as a reduced function device connected together. Okay, that is your star topology. Moving on to the clustered star topology, it is still the network is a star topology, but full function device can be connected each other. Full function device. See, if you can see, all these full function devices are connected to each other. That is your clustered stars. And whereas your mesh topology, you can see mesh topology, it's little bit expanded structure. So the main advantage of your mesh topology is that you will be having multiple paths. Say for example, if I have to communicate from your node A to your node, if I can specify this as E, okay, so you can take via, this is one path, or you will be having a redundant path, or you can have from A to this. So you will be having multiple paths. If any one path is not under it, if it is under failure, you can take a different path. So these are the different topologies which are available. So the next layer, sublayer, is called as your gateways and backhaul sublayer. Okay, so what is meant by your gateways and backhaul sublayer is that if you want to transmit a data which is given by the device, okay, to the central station. So imagine that your central station is very far, then you would require a network which will make this transmission easier. Such network is called as your backhaul network. Okay, so that is the data collected from a smart object may need to be forwarded to a central station where the data is being processed in the central station. As this station is often in a different location from the smart object, data directly received from the sensor through an access technology needs to be forwarded to another medium, that is your backhaul, and transported to the central station. So first it has to go to the backhaul, then it will go to the central station. So who is in charge of this communication? This communication is made possible by means of your gateways. Okay, so the gateway is in charge of this intermediate communication. Communication between the sensors and gateway may involve either the wired technology or your wireless technology. The wireless technology, say for example, DSRC is used for backhaul communication. So what is meant by DSRC? Dedicated short range communication. The choice of a backhaul technology depends on the communication distance and also the amount of data that needs to be forwarded. So which type of backhaul technology depends on these two properties. So when the smart objects operation is controlled from a local site and when the environment is stable, so what type of communication? If the environment is stable, we can go for Ethernet. That is your wired communication. Ethernet can be used as a backhaul. But in the case of unstable or changing environments where cables cannot be safely be run, you will go for a wireless technology. Example is your Wi-Fi. So Wi-Fi is common in this case. So the next sublayer is called as your network transport sublayer. So first you have seen your access network sublayer. Above that you had your gateway and backhaul. Now once the connection is being established, you are going for transmission of the data that is made possible by your network transport sublayer. So the network layer is responsible for managing the transmission of data between the devices, different devices across the network. It handles the routing and delivery of data packets across the network, ensuring that the data reaches the intended recipient. This communication structure, so this kind of communication structure involves three types, that is 3 to 4 types: peer-to-peer communication, point-to-point communication, point-to-multi-point communication, unicast and multicast communication. So for peer-to-peer communication, the example is, say for example, in the smart meter, if 2 meters from meter to meter communication, it is called as peer-to-peer. If a meter to head end station, then it comes under point-to-point. Point to multi-point means gateways or head end to multiple meters. Then unicast and multicast communication, that is the software updates to one or multiple system. These are the examples. To allow such communication structure, we want a network protocol, right? Network protocol with specific characteristics needs to be implemented. And these protocols need to be open and standard based to accommodate multiple industries and multiple media. And two important factors are also very much required, which has to be taken into consideration, that is your scalability and security. So scalability and security are also common requirements. So for that, so preferable protocol is your IP. Internet protocol is a protocol that matches all these requirements. The transport layer protocols are built above the IP. So till now we have seen the network layer. Now the transport layer protocols are built above the IP. They are, what are the common transport layer protocol? One is your TCP and UDP. So you know that TCP is connection oriented and UDP is connectionless. Both TCP and UDP are secured. So one of the important parameter is security, right? So it is secured with TLS SSL, where TLS stands for Transport Layer Security and Secure Sockets Layer. And for UDP, the security is established by means of DTLS, that is your Datagram Transport Layer Security. The fourth sublayer is called as your IoT network management sublayer. So above the network transport sublayer, now you have to have an IoT network management sublayer also. So IP, TCP and UDP bring connectivity to the IoT networks. These upper layer protocols need to take care of data transmission between the smart objects and other systems. Multiple protocols have been created to solve the IoT data communication problems. So some of them, mainly there are two models. One is called as push model and the other one is called as your pull model. Push model means a sensor reports at regular, that is a sensor reports at a regular interval, whereas your pull model means an application will query. Application queries the sensors over the network. Combination of these two, called as multiple hybrid approaches, are also possible. Now, what are the protocols used in this IoT network management sublayer? Mainly there are HTTP 1, 2, 3, 4, 5 protocols which is mainly used. One is HTTP. For data transfer phase, HTTP has a client server component. HTTP is not designed for constrained environments with low memory, low power, low bandwidth and high rate of packet failure. So we go for an improvisation, that is your WebSocket, which is a part of HTML5 specification and provides a simple bidirectional connection over a single connection. The next protocol which is used is XMPP, which stands for Extensible Messaging and Presence Protocol, is based on instant messaging and presence. CoAP, that is your constrained application protocol that runs on UDP and are useful for IoT observation. MQTT, message queue telemetry transport, which uses a broker-based architecture. Now we go for the last layer, that is your applications and analytics layer. First we will see about the two different types of application, then we see about the two different types of analytics. So analytics versus, so first one is analytics application versus your control application. So multiple applications can help increase the frequency of an IoT network. Each application collects data and provides a range of functions based on analyzing the collected data. From an architectural standpoint, one basic classification. So analytics is nothing but processing of the data, right? So analytics means what analytics application is processing the data. This type of application collects the data from multiple smart objects, processes the collected data and displays information resulting from the data that was processed. The display can be about any aspects of IoT network, from historical reports, statistics or trends to individual system states. Whereas the control application is nothing but controlling the behavior of the smart object. That is, this type of application controls the behavior of the smart object or the behavior of an object related to a smart object. For example, a pressure sensor may be connected to a pump. A control application increases the pump speed when the connected sensor detects a drop in the pressure. Next, we are seeing about the two different types of analytics, that is data analytics versus your network analytics. So what is meant by your data analytics? This type of analytics processes the data collected by the smart objects and combines it to provide an intelligent view related to the IoT system. At a very basic level, a dashboard can display an alarm when a weight sensor detects that a shelf is empty in a store. In a more complex case, temperature, pressure, wind, humidity, and even light levels collected from thousands of sensors may be combined and then processed to determine the likelihood of a storm and its possible path. Moving on to the network analytics, most IoT systems are built around smart objects connected to the network. The loss or degradation in connectivity is likely to affect the efficiency of the system. Such a loss have dramatic effects. For example, open mines use wireless networks to automatically pilot dump trucks. A lasting loss of connectivity may result in an accident or degradation of operations efficiency. On a more minor scale, loss of connectivity means that the data stops being fed to your data analytics platform and the system stops making intelligent analysis of the IoT system. And the last one, subdivision, is data analytics versus your business benefits. Due to the processing of the data, what are the benefits for your business? Data analytics is undoubtedly a field where the value of IoT is booming. Collecting and interpreting the data generated by the device is where the value of the IoT is realized. The enhanced data processing can result in a new added value for business that are not envisioned at the time when the system is initially employed. Now moving on to the smart services, the ability to use IoT to improve operations is often termed as smart services. This term is generic and in many cases the term is used, but its meaning is often stretched to include one form of service or another where an additional level of intelligence is provided. Smart services can also be used to measure the efficiency of machines by detecting the machine output, speed, and other forms of usage evaluation. Smart services can be integrated to an IoT system. For example, sensors can be integrated in a light bulb. A sensor can turn a light on or off based on the presence of a human in the room. So these are the topics which you can write for 8 marks. It is little lengthy, but still you can manage to write the important points.